Here, we serve your data with the correct way to describe it.
For sure. So what are you thinking of getting?
Oh, I think I'll order the favorite colors of everyone in the cafe.
Wait, that's easy. You just find the mean.
Actually, colors are nominal, so there's no order and no numbers. For nominal data, you use the index of qualitative variation, the IQV.
But what does that tell me?
How evenly the colors are spread across the charts. For more even data, you have higher IQV. For more lopsided data, you have lower IQV.
So blue wins.
No, there's no winning in nominal data.
Okay, fine. I want ratings of how spicy the food is. Mild to medium to hot.
Perfect, that's ordinal. Since there's order, we use the interquartile range, or the IQR.
But how do we get that?
First, you get Q3 and Q1, then you subtract Q1 from Q3 to get the IQR.
But what about the mean?
You never use the mean for ordinal data. You show it with a box plot, especially if there are outliers.
So the box is from Q1 to Q3, and then the median is the line that's in the middle?
Exactly.
Okay, I'll have the temperatures of all the coffee cups in here.
Great, that's interval and ratio data. For that, we use measures of dispersion.
So you just find the range.
Well, we can do better. We can use the AAD, variance, or standard deviation.
Oh, AAD, I know that one. That's the average absolute deviation, or the average distance from the mean. But then why don't we always use the AAD?
Because it's not algebraically friendly, it doesn't work well in equations, and the variance and the standard deviation use squared deviations from the mean, so everything works well.
So standard deviation is the square root of the variance.
Yeah, variance is in squared units, so standard deviation brings it back to regular units.
So standard deviation is easier to interpret.
Exactly.
Wait, so why do we square the deviations? Why can't the math just be normal?
Because if we don't, the positive and negative deviations cancel out to 0, which means nothing.
Oh, because squaring everything will make it positive, because squaring a negative number means positive.
Yeah, it makes every deviation count in the measure of spread.
Okay, I get that. And what's the thing about dividing n and n minus 1 and...
When we describe a whole population, we have to divide by n. But when we're using a sample to estimate a population, we have to divide by n minus 1, because we're losing a degree of freedom.
Okay, so n minus 1 is like a penalty we get for estimating.
Exactly.
Okay, can I get a normal distribution?
Of course, that comes with the 68, 95, 99.7 rule, where one standard deviation is within 68%, two standard deviations is within 95%, and three standard deviations is within 99.7%.
Okay, so if the mean coffee temperature is 85 degrees, and the standard deviation for coffee temperature is 15 degrees, then 95% of all coffee temperatures are between 55 and 115 degrees.
Exactly.
So what are z-scores? My friend keeps mentioning them and I just have to pretend to agree.
Your z-score is the number of standard deviations your value is from the mean.
Okay, I think I finally understand variance, maybe?
All it is the average of the squared deviations.
But then, why do we have to square the numbers? Can't they just be normal?
I think mathematicians just want to feel cool.
Wait, no, I remember this! Okay, look, if we don't square them, the negative and the positive deviations cancel out, so it's like nothing happened. Wait, but then it makes the units all weird.
That's why standard deviation exists. You just take the square root and bow, normal units again.
Okay, so variance is the math version and standard deviation is the human version.
Exactly, so variance is technically correct, but then standard deviation is actually useful. We're basically professionals now.
Where's the server? Can we get the bill? We just finished the lesson without him.
Thanks for visiting the Statistics Cafe. Please come again if you want your data described correctly.
Thanks for the help!
We never got our coffee.
Is that even a cafe?